Most Toyota owners never think twice about the buttons in their car. They press what they recognize, ignore what they do not, and assume the rest is just extra. That assumption is costing people thousands of dollars in permanent damage every single year. There are 7 specific buttons and controls inside your Toyota that, when pressed at the wrong time or in the wrong way, can trigger failures that no mechanic can fully reverse. These are not warnings invented to scare you. They are real consequences built into Toyota's electrical, mechanical, and software systems. Understanding why these buttons are dangerous does not just protect your car, it protects your wallet. Let's start with the first one. Button number 1, the Stability Control Off button. On most Toyota models, this button is located on the lower center console, just below or near the gear shifter. It typically shows a car with wavy lines underneath it. Pressing it once reduces traction control. Pressing and holding it for several seconds on many models completely disables Toyota's Vehicle Stability Control System, commonly called VSC. Here is why this is dangerous, in a way most drivers do not fully understand. Toyota's Vehicle Stability Control System is not just about preventing skids. It actively communicates with the anti-lock braking system, the electronic power steering module, and the engine's throttle control. When VSC is fully disabled, those systems are no longer coordinating with each other in real time. On wet roads, gravel, or during emergency maneuvers, the absence of that coordination means the car can enter a yaw condition that the driver has no ability to correct fast enough. Beyond safety, there is a mechanical concern. Toyota anti-lock braking system sensors and wheel speed sensors are calibrated to receive constant feedback from the VSC module during operation. Repeatedly forcing the system offline, especially during active driving, introduces irregular voltage signals to those sensors over time. Toyota service technicians have documented premature anti-lock braking system sensor failures in vehicles where VSC was habitually disabled. Sensor replacement on a Toyota Camry or RAV4 typically runs between $200 and $400 per wheel. Multiply that across all 4 wheels, and you have a very expensive habit. Unless you are recovering a stuck vehicle from snow or deep mud, this button should never be held down. Button number 2 is the manual shifter override on automatic Toyota transmissions. Many Toyota automatic transmission vehicles, including the Camry, Corolla, and Highlander, include a shift lock release button. This small button is usually found on the gear shifter console or covered by a small trim cap near the base of the shifter. It is designed as an emergency release to move the gear selector out of park when the vehicle has no electrical power. The danger is not the button itself, it is using it while the vehicle has electrical power and a running engine. When the shift lock override is activated on a live system, it bypasses the transmission control module's internal logic checks. Toyota's transmission control module verifies brake pressure, throttle position, and engine load before allowing gear changes, for an important reason. Those checks exist to protect the transmission valve body and clutch packs from sudden, uncontrolled engagement. Bypassing those checks by forcing the override on a running vehicle can cause immediate and severe transmission damage. Toyota transmission rebuilds start at around $3,000 and regularly reach $5,000 or more. This button has one job: emergency release when there is zero electrical power. Every other use carries real risk of permanent drivetrain damage. Button number 3, the Hill Start Assist Cancel button. Certain Toyota models, particularly the Tacoma, the 4Runner, and the RAV4 equipped for off-road use, include a Hill Start Assist Cancel function. The button is usually located on the lower dashboard panel or near the 4-wheel drive controls, and it is marked with a slope and a vehicle icon. Disabling this system sounds harmless, but the consequences are more serious than most people realize. Toyota's Hill Start Assist Control holds brake pressure automatically for a brief period when the driver transitions from the brake pedal to the accelerator on an incline. When this system is canceled, that hydraulic hold is removed entirely. Here is what many drivers do not know. Toyota's brake booster and hydraulic brake actuator on models equipped with this system are calibrated to work in coordination with Hill Start Assist. Repeatedly canceling Hill Assist and then manually compensating with aggressive brake pedal pressure creates uneven hydraulic stress across the brake caliper pistons. Over time, this causes uneven caliper wear, premature brake pad degradation, and in severe cases, warped rotors from inconsistent heat distribution. Toyota brake system repairs on trucks and SUVs regularly cost between $400 and $800 per axle. Canceling a system specifically designed to protect those components for no practical reason is damage you are choosing to accept. Button number 4 is the auto headlight override switch. On many Toyota sedans and crossovers, there is a headlight stalk or a dash-mounted control that lets the driver manually force the headlights off even when the auto setting would have turned them on. This is usually done by rotating the headlight dial from the auto position to the off position while driving in low-light conditions. This action creates two distinct problems that compound over time. First, Toyota's body control module, which manages all exterior lighting, monitors headlight activation patterns to maintain bulb health and electrical load balancing. When lights are manually overridden in conditions where the system expected them to be active, the body control module records inconsistent electrical draw. Over time, those inconsistencies can trigger phantom warning lights, false bulb failure alerts, and in some Toyota models corrupt the automatic light sensor calibration that the system uses to decide when lights should activate. Second, on Toyota models equipped with Toyota Safety Sense, the forward-facing camera mounted behind the rear-view mirror partially relies on contrast data from headlight timing to support lane recognition in low-light conditions. Manually suppressing headlights in those conditions degrades camera performance and can cause lane departure alerts to activate incorrectly or to fail when needed. The auto headlight system exists to protect both the driver and the vehicle electronics. Overriding it habitually creates failures you will be paying to diagnose long before you ever understand what caused them. This is button number 5, the engine idle up button on Toyota diesel and certain truck models. Some Toyota Tacoma, Tundra, and Land Cruiser models come equipped with an auxiliary idle up button, often located on the lower dashboard near the four-wheel drive controls. This button manually raises engine idle speed and is designed for specific applications, such as powering auxiliary equipment on work vehicles or maintaining battery charge during stationary use of high-draw accessories. The critical mistake that causes permanent damage is pressing this button and then driving the vehicle. Toyota's idle up system raises fuel delivery and engine RPM in a way that is specifically calibrated for a stationary, zero-load condition. When the vehicle is put into gear and driven with idle up active, the transmission receives a throttle input signal that does not match the driver's actual pedal position. This confuses the transmission control module and forces the torque converter clutch to engage under conditions it was not programmed to manage. The torque converter clutch on a Toyota automatic transmission is one of the most expensive single components to replace in the drivetrain. Damage from improper engagement scenarios typically requires full transmission disassembly to correct. This is a 4-figure repair caused by a 2-second button press. Idle up is for stationary use only. If you drive away with it active, you are actively damaging your transmission with every mile. Button number 6 is the forced DPF regeneration button on Toyota diesel models. Many Toyota diesel vehicles, including certain Land Cruiser and Hilux models where diesel is available, include a diesel particulate filter, known as DPF, along with a manual regeneration button. Pressing this button in the wrong conditions causes failures that are severe and expensive to reverse. Toyota's DPF regeneration cycle raises exhaust temperatures to between 1,100 and 1,300 degrees Fahrenheit. The system is only safe to initiate when the engine is fully warmed to operating temperature. The vehicle is at a safe stationary location away from flammable materials, and the exhaust system is confirmed free of physical obstruction. Pressing the regeneration button on a cold engine forces those extreme temperatures through metal that has not expanded to operating tolerances. The rapid expansion difference between cold metal and superheated exhaust gases accelerates cracking in the DPF substrate, damages the diesel oxidation catalyst located directly upstream of the filter, and can warp the flex sections of the exhaust system. DPF replacement on Toyota diesel platforms starts at approximately $2,000 and can reach over $4,000 including labor. This button exists for emergency maintenance, not routine use. Using it incorrectly destroys the very component it is meant to protect. Button number 7. The maintenance reset button used at the wrong mileage. Nearly every modern Toyota has a maintenance reminder reset accessed through the multi-information display using the trip meter stalk or steering wheel controls. This reset clears the oil life and maintenance interval reminders after a legitimate service has been completed. The permanent damage caused by this button is indirect but consistent and well documented in Toyota service history. Toyota Engine Control Unit does not simply count miles to decide when your car needs service. It calculates oil degradation using real data, engine temperature cycles, cumulative load hours, average RPM, cold start frequency, and trip duration patterns. That calculation is more accurate than any fixed mileage interval. When the maintenance reset is pressed after a quick oil top-up, an incomplete service, or simply to silence the warning without any work being done, the engine control unit resets its baseline to 0. From that point forward, the system operates on false data. It will not warn you when oil has genuinely degraded to a dangerous level, because it believes the clock has just restarted from a fresh service. Toyota engineering data shows that engines operating on incorrect maintenance interval data develop sludge accumulation 30 to 40% faster than engines with properly maintained reset histories. Sludge in a Toyota engine is not a cleaning problem. Once sludge reaches the oil pickup tube screen, the variable valve timing solenoids, or the narrow oil passages feeding cam journals, those passages do not fully recover. Variable valve timing system replacement on a Toyota 4-cylinder engine runs between $800 and $1,500. On a V6, costs regularly exceed $2,000. Pressing that reset button without completing a legitimate service is telling your engine that everything is fine when it is not. The engine believes you. The damage follows quietly. Here is the pattern that connects all 7 of these buttons. Every single one of them bypasses a system that Toyota engineered to protect components. The vehicle stability control button bypasses sensor coordination. The shift lock override bypasses transmission logic checks. The hill start assist cancel bypasses brake hydraulic protection. The headlight override bypasses body control module calibration. The idle up button bypasses throttle management under load. The diesel particulate filter regeneration button bypasses thermal safety tolerances, and the maintenance reset button bypasses the engine control unit's real-world oil degradation data. Toyota did not build these buttons to be ignored. They built them for specific, controlled situations. The problem is that most owners press them out of curiosity, frustration, or habit, never knowing that the damage is already beginning. The best Toyota maintenance habit you can develop is not about what you add to your engine. It is about understanding what your Toyota is already doing to protect itself and choosing not to undo it. If you are enjoying this video, consider watching the next one, where I am sharing the exact habits that help Toyota engines cross 300,000 miles without a rebuild.